Hey guys, welcome back to my channel. In today's video, we are going to see how to solve this problem called longest subarray with some k, right? So the question is pretty simple. We just have to find that longest subarray that has some k, right? So first of all, let's understand what is subarray. What is subarray? Subarray is the contiguous. It's the contiguous part of an array, which basically means continuous, right? So 1 and 2, these two are contiguous part. 2 and 1 are contiguous part. 1, 3, 0, this is a contiguous part. But 3 and 1, these both are not contiguous, right? Why? Because 3 is here and 4 is in some other location. 4 is in some other location. They are not together, right? So that's the reason they are not contiguous, so they are not subarrays, right? So let's have a look at some examples. 1 to 1, 1 to 1, yes, it is a subarray. Why? Because they are contiguous. 2 1 3, 2 1 3, right? 2 1 3, this is a contiguous part, right? So it's a subarray. 306, 306, since they are contiguous, it's a subarray. What about 301? 301, it's not a subarray. Why? Because see, 6 is not a part of 301. If it would have been 3061, it's a contiguous part. But 3, 0 and 1, they are not contiguous, so they are not a subarray. Similarly, 362, 362, they are not contiguous, hence we cannot call them as a subarray. 36, 3 is here, 6 is here, so they are not subarray. So now we got to know what subarrays are, right? So what the question says, we just have to find that subarray whose sum will be k, but I need the longest among them, right? And I have to return the longest length. So basically, let's say a subarray is there, right? These all are the elements, let's say. I'm getting the sum. I'm getting the sum, and then I'm checking like if sum is equals to k or not. If it is, then get the length. Then store the greatest length that we are getting, and that's our answer, right? But to do this, we need a subarray, right? So the most brute force way that comes to my mind is to generate all possible subarrays, and check if sum is k, right? If it is k, then we will do the operation here. We will get the length and then store the maximum length, right? So how to generate all possible subarrays? So let's have a look at this diagram, right? So let's say I is the starting position and j is the ending pointer, right? So let's say this is the first subarray, only this, and 1 2 will form the next subarray, and 1 2 1 will form the next subarray, right? And 1 2 1 3 will form next subarray. So basically what I am doing, I am keeping a pointer here, let's say I, which is the starting point, and ending point I am actually iterating through all these indices, that is j. Sorry, including I also, because see, 1 is also a subarray. A single element is also a subarray. So these all will be giving subarrays. And now what I am doing, I am going to increment this I. Now the subarrays will be starting from second index, right? And then it will be ending in different indices. So each of them will give subarrays, right? So basically I will go from 0 till n minus 1, and j will start from I and it will go till n minus 1, right? And then once I got that I and j pointer, which basically means that I got the subarrays, which is from I to j. Now I am traversing from I to j using a pointer k, and I'm getting the summation of all the elements. And here I'm checking if the sum is equals to k or not. If it is, then get the length. Now we need to find the maximum length, right? We need to find the maximum length. So first of all, let's see, given I and j, how to find the length. It will be j minus I plus 1. How? Let's say I and j is pointing to a single index, let's say 0th index, right? So I will be 0, j will be 0. So in this, length will be I minus j plus 1. It gives 1. Let's say I is pointing to 1 and j is pointing to, let's say, 4, right? 0, 1, 2, 3, 4. So here I is there, here j is there. The length is this much. So by the formula, it will be j minus I plus 1. Okay, this is not I minus j plus 1. It's basically j minus I plus 1. So 4 minus 1 plus 1 will give 4, which is basically the length, right? Basically from starting till ending, the length minus from starting till I. This is j, this is I. When we subtract, we will get the length of this j minus I, which will give the length, right? So I got the length, but what I need to do, I need to store the maximum of all those lengths, right? So first of all, let's say I'm going to keep a variable, let's say max length equal to 0, and then I'm comparing, bro, this length is greater than max length or not. If it is, this length will sit on max length, right? So likewise, it will go to all the possible subarrays and get their sum and check it with sum equals to k or not. If it is, it will get the length and get the maximum length also, right? So the time complexity will be of n cube. Why? Because there are 3 loops. So roughly it will be of n cube. Not exactly, but roughly, which we don't want. Can we optimize? We can try optimizing for this extra loop. So what I'm going to do, I'm going to cancel out this loop. Cancel out this loop. How? Let's say in the diagram. Let's say I is here and j is here, right? It was 1, 2. And in the next iteration, this 1, 2 will become 1, 2 and 1, right? This 1 got added. And for the next iteration, it will become 1, 2, 1 and 3. So 3 got added. So do we have to iterate from I till j all the subarrays? I think no. As the j moves forward, we will keep on adding the jth element, and after adding the jth element, we will have some check there itself if it is equals to k, right? So we don't have to iterate from I to j separately, but rather while iterating for j, I will be keeping a sum. So the code looks something like this. I will go from 0 to n minus 1, but before starting the ending point, I am keeping sum equals to 0. And then as j pointer moves forward, I am storing a sum of those elements. And after adding up, and there itself I am checking for this condition. If it is satisfying, that means if the sum is equals to k, then length will be equal to j minus I plus 1, which will give the length of the subarray. Then here I am storing the maximum length, right? So the time complexity will be of n square roughly. Why? Because we removed that k extra loop. So this video is all about brute force. I will be sharing the optimized approaches in the coming videos. So that's it for the video. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.